Okay, hello. Good day for everyone. For me, it's good afternoon where I am, but good day from wherever you are seeing this webinar. Okay, so let's start. Yeah, I don't have any feedback about the amount of people that is viewing right now, but I suppose that in any case you can interact through the chat, through questions. So feel free to interrupt me at any point because it's a whole hour, this webinar. So in order to make it more interactive, don't hesitate to interrupt me and just post your questions anytime. Okay. But basically, this webinar is about sovereignty by design, what it means, sovereignty, what it means to provide it by design, especially what is the value of sovereignty by design in the context of agricultural data and in the context of the initiative of data spaces and in particular data spaces that are applied to agriculture. Yeah, I'm Roberto García from University of Lleida, where I am associate professor in the computer science and digital design department and working these last years in digitalization of agriculture, data management, and related topics. Okay, so let me then start, okay, with the first slide. Okay, this is an introduction, okay. Yes, this is context that you already know quite well because most of us here are about just these ideas. We come with these topics, with these problems on mind. That digitalization and data is critical for the transformation of the agriculture sector. We see this everywhere in the world, not just in Europe, where I come from, but in other parts of the world and through other calls in this event, you have already perceived this same preoccupation. The idea now, or what we are working right now, is in sharing beyond open data. We have a lot of open data related with agriculture. We have recently done an article just about a review of open data in agriculture, and we have seen that this a quite good amount of data, especially the satellite data, Earth observation data. But what comes more complex is when you want to share data that is beyond that, the data that you want to freely offer and share with others, data that has personal data inside, or sensible or strategic data that you want to keep under control. Okay, so that's the biggest preoccupation, but it's also where we perceive that there's more value in data sharing. Data spaces is basically an attempt to solve that problem, to break this barrier when it comes to sharing this kind of data that you want to keep control on it. And it's basically based on an open and decentralized infrastructure, because what you want to avoid is that all the data is collected and accumulated in a centralized location. This has happened a lot till now regarding personal data through social networks and so on. We want to avoid that in the agriculture domain. So this infrastructure should guarantee that when you share data, you remain sovereign on that data. That means that I was talking about data spaces and this approach, that the idea is to try to facilitate data sharing of data that is sensible, strategic, or that contains personal data, basically guaranteeing that the participants remain in control of that data so they can decide the uses that it can have, the kind of the time frame it can be used, okay, and they should be informed at any point about the new uses that might be intended. And basically, as I was mentioning, this is based on there is not a central data repository, and it's basically one of the options that there are direct interchanges among the participants. So this avoids having to put all the data in the same place. And this is just a starter for power imbalances, because who accumulates the data is accumulating more power. So what data spaces provide is mechanisms to overcome these barriers. That is basically, there is a lack of trust when sharing data in that what is who you are sharing the data with, what is this institution going to do with your data. So this is a reluctance that it's common and comprehensible completely, because this is what is happening, for instance, with our data when we interact with many of the services that we got used to in social networks, for instance, that the institutions that are behind are accumulating that data and using it for other purposes. And like recently, Facebook that is requesting that they want to use our pictures, the content that we share to train their artificial intelligence. In some cases, given the legislation, they have to ask for permission, but in other legislations, they can do that because when you sign the terms and conditions, you provided to them that option that they can use the content that you upload without any hesitation or any additional consent. So this is something that is putting barriers when in an agricultural domain, we ask, for instance, farmers to share the data that they are generating. So in order to solve that issue with trust, the idea is to provide this data sovereignty in the sense that we can ensure the stakeholders that they don't get exploited, in the sense that the data that they contribute, they're going to get fair compensation for it. Also that they can always decide on the uses that are intended. So it's more feasible for them to get fair conditions because they can negotiate. Okay, otherwise they cannot even negotiate the conditions. And also that we perceive or we see this sovereignty, and this is starting now to be our vision of these data spaces and how to approach them. We see sovereignty at the level of the states. This is the most common approach, the idea, especially in Europe, that we want that the data doesn't leave the EU borders. So this is especially common right now with personal data. You need, or it needs to be stored in the borders of the European Union. Also at the level of organizations, so also that you can guarantee an organization that the data that they are sharing, the remaining control, and also even to individuals. Individuals can also decide on their data. And this is common, for instance, in health domain, where the link, the data and the individual is more evident, but also can be with an individual farmer that owns his exploitation. And there we have just basically a link one-to-one between the farmer and exploitation. So why is this relevant for the agriculture sector? Because as many studies have shown, and this is just one, you have here the reference that was conducted in Australia with 1,000 farmers. When they are asked about if they know the terms and conditions related with the data collection for the products that they are using, or whatever service they are getting to assist them on the field, they mostly don't know at all what are the terms and conditions. Like we do with social networks, it's also common there. We just accept, we go through these screens with a lot of text, incomprehensible text, and we just accept, and later, maybe sometime we will realize what we have accepted when we see, for instance, that our picture has been used to train an artificial intelligence. No? And also on the same level, even if it seems they are not preoccupied because they are accepting the terms and conditions without hesitation, on the other hand, they are not comfortable at all with these institutions. They are getting access to their data if they are making profit from themselves. They are not comfortable with that. So this is also a problem. So they are preoccupied, but maybe we are putting too high barriers in, for instance, terms and conditions, or the way they can negotiate these conditions at the beginning, because usually is that you accept and you can use the service, otherwise you are barred completely from the service. So the power of negotiation that they have puts them in this situation that they are quite sure that it's going to be used by these institutions. Right? That is the last question. How much they trust that this data that they're shared with these institutions is not going to be shared further with other parties. You can see that they don't have much trust on all these. No, most of them don't have any trust at all, and more than half are more untrustful than trustful. So this is a problem that it's perceived, and when you talk with farmers, is evident, and they are suspicious that the data that they are providing is being used for other kinds of uses beyond what they have authorized or what they think will be the fair conditions for that use, and also that they are not getting a fair compensation for their data. We have also analyzed what might be the impact of data sovereignty from the point of view of the values, from an ethical standpoint for different kinds of stakeholders in data sharing in agriculture, starting from farmers and farmers associations, but also taking into account advisors, agribusinesses, technology providers, intermediaries, also public and regulatory bodies, and the society as a whole. The impact that this data sovereignty that might have, the value capture is the first thing that is provided by the guaranteeing data sovereignty to these stakeholders. In the case of farmers and farmers associations, is the control. They perceive they are now in control. The negative impacts are also considered in this case. One might be that privacy cannot be guaranteed completely, as more data is shared at some point just by the aggregation of data. There's the risk, and it increases with the amount of data that you share, that you can be identified. Even if you put a lot of anonymization mechanism in the middle, it's a risk that you cannot completely avoid. And also, we here identify additional values, opportunities that data sovereignty might open. And one of them is that farmers and farmers associations, beyond being in control, they can also be informed every time they consent to any kind of use. And we did the same for other stakeholders. There are some that are impacted negatively compared to the situation right now. For instance, for technology providers or agribusinesses that are now benefiting from free access, mostly to the data, they will be impacted positively in the sense that they will get more trust, because we have mechanisms that provide some guarantees, for instance, to farmers that they are going to behave properly, and we will see how we can implement that. But on the other hand, we have negative impacts, for instance, the autonomy. Previously, they can just collect the data, or we suppose in many cases it might happen like that, maybe not in all, but now they will need to go through this consent mechanism. So the autonomy for them is reduced, because now they depend more on who is generating the data to be informed, to consent. So the autonomy is reduced, but this is something that goes, this negative impact goes from the higher good of all the overall values of all the stakeholders. So we have to put here some kind of balances in any case. Some of the stakeholders will perceive also that some of their values are impacted negatively by the fact of putting sovereignty in place. Like the same for public and regulatory bodies, if they are also affected, if they are not able to collect the data without consent, they will also be impacted negatively in that sense. So the more data that they can get access to will increase accountability. And for the society as a whole, it's also a problem with privacy in the sense that maybe they can be also identified as a whole, even if they are not participants directly on or not producing participants in the agricultural sector, just consumers. It might be also a risk. But on the other hand, there is a benefit from this overall situation of having data sovereignty in place. Okay, so this is basically an analysis that we conduct beforehand to guide how we design these agricultural data spaces based on the mechanism of data sovereignty. So as we have seen, we have that barrier that with trust we can reduce a lot this barrier, but we also need incentives, ways of motivating, for instance, small farmers to share their data, to get into the digitalization, the use of data for advanced services that help them in being more productive, more sustainable. But also to do that step, they need to get a fair compensation also from the data that they are contributing. This is really difficult. We have seen this problem also, for instance, in music. When you have something that is digitalized, it's really easy to copy and disseminate that. This happened with music. We had a big crisis related with music, the people holding the copyrights on that creations. Some proposals were based on controlling how you copy, how you access music. Basically, the initiative was called Digital Rights Management. This is something that right now is quite forgotten. Right? The approach is different. Now the industry has discovered that the streaming is a better way of dealing with this problem. No? This ease of copying and disseminating content, providing music more like a service. Can we do something similar for data, providing this sovereignty by design so you are in control of your data? There are different approaches. One of them is based on what is to share peer-to-peer between the stakeholders directly or using APIs intermediaries. But here the problem is that it's difficult to enforce. As soon as you have copied, even if it's peer-to-peer to another party, your data, it's really difficult to put mechanisms that enforce the rules that you have defined about how that data can be used. They can just copy, move it around, and it escapes completely out of your control. Like with music and peer-to-peer networks, it happened quite the same. Okay. So as soon as you have a digital copy of a song, you can start copying and sharing with others, and it's out of control. The same might happen, or it's happening with data. And even if you put mechanisms that try to put rules, and the real problem is how to enforce them, right? How you guarantee control completely of the system where that data is copied, so it cannot get out of there. It's really, really difficult to do that. Yes, the only option is that you have full control of the devices that are being used, and this is not practical. And this is the same problem that happened with digital rights management. So what is our proposal or our approach to providing this sovereignty by design? So the system itself is guaranteeing that you will remain in control of the data. It's basically technologies that are already being used, for instance, in computing statistical data based on anonymization, based on multi-party computation, but especially in the combination of what we call data rooms. That is basically, instead of moving the data to send wherever it is going to be processed, is the data remains under your control, and it is the algorithm that makes the processing who visits the data. And this combined with trusted execution environments and also privacy of the output. So you guarantee that the data you are getting as a result doesn't contain sensible data or personal data, is a mechanism that might help in this regard. And to put this clearer, we have this picture about how we view these data rooms. That in fact is not something that we have invented. They even exist in the real world. Hey, when there are mergers between companies or acquisitions, they have physically this, what is called a data room. It's basically where you have all the data about the company that you are going to buy or that is going through a merger. So all the data about the accounts of the company that is really sensible data stays in a room. You can, the negotiators can enter that room, but without mobiles, they cannot take any paper out of that room. Okay, they cannot take notes or just small amount of notes, and you control when they get out of the room what they are taking with them. So that's the same in the digital world, what we are proposing. And the idea is that you have your data in one of these data rooms. Let's say this is your production data, the yields that you are generating, everything that is collected in your field. And it's you who decides which algorithms, for instance, to compute optimizations, making recommendations. You decide which algorithms can go into this digital room, and also you control what they take out these algorithms with them. They cannot take full copies or partial copies of the data. This way you also guarantee checking that there is no personal data. You also guarantee privacy, but also you check that the data that they are taking out, for instance, if it's aggregated data, it's at a level that doesn't allow you to be easily identified or doesn't reveal critical information about you or your farm, and also can be an algorithm that is training an artificial intelligence model. So just checking that the model is at the level of detail that doesn't reveal any sensible or personal data. This is the approach that we are proposing and what is based on the experiments that we are doing with data spaces. The implementation, how this is actually implemented, is through an approach that is called compute to data. That is basically you don't move the data where it is going to be processed. You have dedicated places provided by trusted parties, or maybe by yourself or a cooperative you are part of. It will depend on the level of technological capabilities of the institution. But the idea is that it's a trusted third party where the data is combined with the algorithm, the computation happens, the aggregated data is computed, or an artificial intelligence model is trained, and what gets out and what is received by the consumer is just the result of that computation. So at no point they are getting access to the original data. And also these trusted environments are implemented in a way that these data rooms, when the computation finishes, everything is destroyed, so they don't retain a copy of the original data. Okay, so let me see if I have here something. No questions. Okay, so yes, continuing. There is already an ecosystem around this idea. It's called the Pontus X ecosystem. Is quite connected with the Gaia X initiative, that is the initiative at the EU level, European level, about these data spaces and sovereignty regarding data. In this ecosystem, there are different portals related with different domains. We're working especially in the agriculture domain in this context, but with the idea that all these data spaces can be connected. So at the end, you can mix data from agriculture, from earth observation, from commercialization of these products, for transportation, whatever other domains can be easily combined, because this is a federation, a combination of all these data spaces and the data they contain, and also the algorithms. Because to these data spaces, you don't just share the data, but you also share the services to process this data. This is based on technologies. Here I will not enter into too much detail, but basically we have this provider that is the mechanism that is implementing these data rooms, and is part of all this architecture that is also based on blockchain technologies. That is a way We enforce the conditions of use, also the incentives, because we can put here mechanisms for the payment of the data, for the payment of the algorithms. All this can be monetized. And we are conducting a proof of concept based on these technologies. The idea is that we can provide control on the data, so this sovereignty. We can also provide ownership and transparency in the sense that all the participants are identified. They use the credentials that identify them. They are connected also to the services or to the data that they are providing. And we can also transparently trace everything that happens because everything is recorded on the blockchain. This proof of concept is already available online. You have here the link. And we have conducted some experiments with real data, with real algorithms, just to explore what is possible and if we can guarantee this level of sovereignty that we are trying to attain. One of the use cases is related with a project that is about applying artificial intelligence to the pig sector, to pig production. Basically, we're collaborating with a center that is affiliated to the university, that is an experimental pig farm. They have, for instance, among other things, automatic feeding machines. They have sensors to collect the conditions on the farm. They also have cameras. And the idea is that we are providing to them this compute data environment so we can guarantee to them that the data can be used, but it's not escaping their control. That is something that they were complaining because this happens to them a lot. This is basically a research institution, and they have seen many times that the data that they are producing is finally, they can see it published in articles somewhere else and without any kind of attribution to the original creators of that data and the efforts that they put on that. Okay, so the idea is to provide that environment to them. And we have started, for instance, with the information connected with the images inside the pig farm of a pen, all the porks that are in that pen, in the pen. And the idea here is that we can, or we have developed an algorithm, different institution, not ourselves directly, but we made that available through the data space. So now the experimental farm can share a file, a data set that is basically a collection of pictures and a video of inside the pen. And we can apply over that set of images an algorithm that is basically identifying the porks, then tracking them, and deriving from this information metrics about the well-being of inside the farm. So how much does each individual pig move, how much time they expend in the area where they feed, in the area where they get water, okay? So the idea is that you can apply then the algorithm to your data, or other parties can do that, but they just get access to the result that are the metrics. They don't get access to the individual pictures from inside the farm. So they will not get the video that you're seeing here will not be available to them. They just can get the metrics of the well-being of the pigs. So this is a guarantee that the farm appreciates a lot because this is many cases sensible data that you want to reveal. At the same time, they can monetize all of these different components of this particular service can be monetized. It's difficult to perceive here in the image, but everything has a price. So you can put a price on the pictures. So this will go to the farm. You can also put a price on the algorithm that you want to apply. So this will go to the technology provider. And even there's a price for the computation time that you use in the data room. So all the actors can get a fair compensation for the resources that they put into the data space. Beyond that, we are also exploring other use cases, and these are more related with data integration, because it's not just a matter. For instance, here we are collecting data from the feeding machines. The problem is that this data comes in very different formats. So we'll need, each feeding machine, for instance, has different formats for the data. So basically we're getting like tabular data with each animal, the date, the time, how much feed did they consume, the weight of the animal, because they also weigh the animal each time they go to feed. So the idea is that each machine is producing different kinds of data, maybe using different units of measure, different formats, different structures. These tables are different depending on the machine. So the bigger problem, or the biggest problem beyond this control that we were talking so far, is also the integration of the data. So in this case, what we are proposing is, okay, we are just uploading, or the first approach will be just to upload the data, whatever is the format that you have. Then based on this compute to data environment, you can, for instance, run algorithms that allow you to inspect the data to get an idea about what is the shape of the data. To do that, you have to consent, as we have seen, and you are always in control. You just can see the algorithms that you can apply because you have previously consented that they can be applied over your data. So you can run, for instance, in this case, is an exploratory data analysis algorithm that is just generating for us. Okay, let me see. It appears now. Okay, it's generating a report about the shape of the data, but without getting to you a copy of the actual data. But in any case, this is really useful because in this context that we are guaranteeing control, and this is a way that you can get yourself an idea about the data that may be interesting for you to use or not. And then beyond that, we have also the process of, okay, this data is interesting, but it's in different formats, comes from different machines. How can I integrate all this data? Our approach in this case is to use an approach that is called the pay-as-you-go model. That is basically that you allow anyone to share the data in the format that they have it. They don't have to make any effort beforehand to share the data, because otherwise this is a barrier that is going to be difficult to overcome. So the idea is that you can share the data in whatever the format you have it, and is later where you will put the efforts for the semantic integration of all that data, trying to identify patterns, and based on the interest of who might be the potential consumer, or maybe who is producing the data to enhance and make it more valuable for the consumers. For this, we are using technologies related with the semantic web and knowledge graphs to basically try to model the underlying concepts in the data. So getting the abstractions that are behind the data. And there are different standards for this. I will not enter into details, but you have all the links. And you even have here a video that is linked from this that makes an introduction to these semantic technologies, how they work. But I will go just to a specific example. You have this as a reference for you. I will go to a particular sample to make it clear how it works. So for this semantic integration, what you can do is to invent all the terms or the references, reference codes, but it's much more convenient in order to make it easier for everyone to interact, to use already existing vocabularies, or what are called ontologies, that are these formalizations, agreements about how to model what is there in the world. And there are already many initiatives in that regard that make proposals about how to model, for instance, the measurements of the sensors in agriculture and also in other domains, and also different aspects of the whole value chain in agriculture, from genetics to the final consumers. There are ontologies that are basically vocabularies that provide reference terms, the ways that we can understand refer in the same way to the same term, so we can make our data interoperable. And one example of this, as it was mentioned, is how to model the data that we get from the sensors. In this case, it will be from the farm. we are using this ontology or this vocabulary that is called SARF, that is for modeling sensor data. And it's basically based on reducing it to the fundamental concepts, that is to model measurements, what is being measured, what is the unit of measure that we are using, what is the device. So this way, even if we have measurements from different machines, it's easier to integrate, even if they have different units of measure, because we have that information explicit in the data. So we are exploring also that in the context of the data space. So in addition of providing services, for instance, to explore the data or to train artificial intelligence model or compute aggregations, we are also providing mappers that are capable of getting the data in whatever is the format. They are developed, usually will be developed by experts in the domain, but they have the incentive that they can also monetize their contribution. And basically what they will do is to get this original data, identify which are the different concepts that are in that data, and make that explicit. And here we have a representation of that. Basically, we have here that this data set is basically containing two different measurements. Even if it seems just one line is for each pig, at a moment in time, we're measuring how much food did the animal eat, but we're also measuring the weight of the pig. So we are generating two measurements for each of these lines, connecting it with the pig. We can also connect it with other entities, like where it is the pig. So later we can connect it with the environmental conditions. The idea is that we are contextualizing the data, so it's easier then later to exploit that data. And we also have other data sets, for instance, generated by these machines, that is the daily weight, okay? We get this information, is each pig with its identifier, each date, the weight. But we don't have context here about how this weight is measured. So we also need to make that explicit. So modeling that this is a KPI, an indicator that is generated each day based on an average of the individual measurements. So we can also model all that and make it connected. So the final shape of the data that we generate is like big graph that is connecting all these different files and also contextualizing. So we know that these are measurements, that one is for the weight, the other is for the intake, well, that's the unit of measurement that is used in any case. Okay, so all this is provided. Here you also have links that you can use to play with these technologies. Here you can actually use this particular example and put it into practice and see how it works, how you can generate different formats from the data and even visualize. And if we have time at the end, I can also show you and go through this example. But I wanted to leave some time for questions in any case. Then the important thing here is that through this process, we can also enable something that we think is high value for farmers, that they can create these data cooperatives where they mix different kinds of data, they make it uniform through these data mapping tools using semantic technologies, making the meaning, the context of the data explicit, but also aggregate information from different farmers, put it all together. So this has a much higher value for the technology providers, for instance, later, for instance, to train their artificial intelligence models. This will be like a new revenue stream for, in this case, the farmers. But on the other hand, the data space is also a mechanism for technology providers also to monetize what they develop. For instance, in this last step 4, basically, a technology provider has developed, for instance, a fattening model that is capable of predicting the evolution of the weight of the pigs, so to optimize when they are brought to the slaughterhouse. So they can also, after maybe investing in purchasing some of these data sets to train it, they can also then later monetize. So they offer this as a service through the data space, and the farmers can just purchase that model and get some predictions, get some reports, and consume them. But always, as previously in this case, with the guarantee that the data they are using from their farm to make these predictions is not reaching this technology provider or going beyond their control, because all this is happening in one of these data rooms. And as you can see, we can, in all these cases, monetize all these aspects, the data set, the algorithm, and even the computation time. So you don't have even, as a farmer, to invest in big resources to produce or to compute that report. This is also something that is provided by the data space. Beyond that, we're also exploring ways with these semantic technologies and data spaces. This integration is also a big problem. There are a lot of initiatives trying to map, in this case, is what is happening at the Spanish level. There is a global national level farm registry that is collecting information from the individual farmers, all that they do in the farms. They are using specific catalogs to being able to report, and this is being proposed to do digitally. It's also done by hand. You have to identify which is the crop that you have cultivated, the yields, which practices you have used, because there are some support, these grants that are coming from the practices that you are using that are encouraging sustainability. But one problem that we have is that this is just a way of describing these yields, these crops. And the problem is when you try to go, for instance, integrate this at the European level or at the global level, you need vocabularies that are common for everyone. So here we are also exploring how to map the crops that are identified in this catalog to global vocabularies about the different kinds of crops that exist in different languages. Here it's also a big initiative at the United Nations that is the agri-food vocabulary that can be also used. The idea is that we can do this integration at this level. And here also as a reference, I just providing here this tool that we are using that is very convenient if you are dealing with this kind of cleaning data, reconciliation. So you connecting one vocabulary that is used in a particular domain or a particular country with global vocabularies. In all these cases, this is a very useful tool that is called OpenRefine that will help you a lot. In this case, we are getting directly from the catalog in Spain all these lists of products, and we are reconciliating this with AgroBook. So we can see that in some cases, a direct connection has been identified, even if it's in different languages, because AgroBook is in multiple languages. But from that point where we have identified that these two terms in the vocabulary that we are connecting in the reference one are the same, then we get all these. At the end, we are getting this term internationalization by default, because it is connected not by a particular term, but to the concept, no? That is, for instance, maize that might be expressed in different languages. That is something that AgroBook provides. Also, well, as a curiosity, all the data space initiative that we are conducting is integrated with this initiative at the European level that is called GaiaX, that is also expanding to other countries around the world. In that sense, that is an initiative that tries to guarantee this data sovereignty, this control over the data, but also identifying the parties, also tracing who is using what, the compensations. All this is tracked by the system. We're also exploring going also to the edge. So in some cases, maybe we're also interested in having these data rooms even in the devices or in the tractors that are operating on the field to provide that sovereignty to that level of detail. Also, we're exploring in the context of a project that we're conducting right now, also that based on this sovereignty, we can even make that different manufacturers of these feeding machines can share the data among them, for instance, to train artificial intelligence models, because they are going to be better if it's trained over more data. But at the same time, we can guarantee to them that no one is seeing the data from that is generated by the others, and that they remain on control over the data. And this is especially relevant in this project that they also included here, like just as a reference, because it's an initiative at the European level that is for testing and providing services to test and validate solutions by third parties, companies that are making the solutions, validate that that solution is working properly, that is a solution that applies artificial intelligence or robotics. And the idea is that in that context, we can guarantee to these companies that they are coming to validate their systems that they remain in control over the data. And I just have included here some additional slides about this project, just in case you are interested. And the actors that are participating from Spain in this project, and what is the service that are provided. That is basically to help companies reach that are developing these solutions in the agri-food domain, reach the market that is just the toughest part of the process to really validate that the solution works, getting the trust of the final users, and testing that what they are proposing, for instance, to predict the weight of the pigs is actually working under real conditions. And that's all from my side. Thank you very much for your time. I haven't seen so far any questions or comments through the chat. So I hope someone is on the other end. And now, please feel free, if you are there, to ask questions, comments, if you want me to get into further detail of any part I have covered, because at the end, I just went through many things more quickly. Please let me know. I suppose you have access here to questions and answers. That is the tool. But I have been told that there's no way to participate in these sessions by talking. So I think the only way is through the chat and through the questions that can be written also through Zoom. And in any case, if there are no questions or comments that you want to make, I also have here my personal webpage, okay, that you can, through that you can get my email or my contact details, and you can just contact me if you have any additional questions or comments that you want to make, or you want to know more about different tools that I have presented. Okay, so I suppose there are no questions. I hope everything was clear. In any case, thank you very much for your time. Almost time. And we'll just close then the session. And I can do is to share my email through the chat. In case. And I will also share a link to the slides. Well, it's not the same version, but one that has similar content in any case. Because right now I don't know of mechanisms to share. Okay, let me see if I can. I'll put here the link. This is a version quite similar to the one that I have used of the presentation. And in any case, I will try to make also available the one, and the particular one that I've used, but it's mostly the same that you have seen right now. Okay, so thank you very much. And I will then close my stream. Thank you very much. Bye.